Hello, welcome to Module 3. This is based on Chapter 3 in your text, Power and Energy in Derived Units, and let's get started. So one of the first things you'll see is this little table here on page 47 that just gives you a quick overview of how to do various equations, so velocity, acceleration, force, energy, and power. SI in the little box above is System International. This is the English version, which in the United States we do use things like foot-pounds, and it's pretty common. And I will show you BTUs, foot-pounds, degrees Fahrenheit later on in this semester because we do use it for energy analysis. So it's important that you know that unit and are familiar with it since it's what we use commonly in the US. And then conversions for everything from the US system to the System International. So what is 1 foot per second equal to? Well, it's 0.305 meters per second, and so on and so forth as we go down. 1 mile per hour over here, right? For the speed, and it's that, and then meters per second, your velocities. So each one has its conversion. This is another table that you have, and this one is a spaghetti graph table, which allows you to move back to determine what everything is. So for example, if I want to know what is a joule is a Newton times a meter. Well, what is a Newton? A Newton is a kilogram times a meter in seconds squared. And what does that all translate to? Well, it goes back to kilogram, it goes back to meters, and it goes back to seconds over here in time. So it gives you this little spaghetti graph, lets you follow things back to where it came from. And you might find this helpful. So, it's one of those slides to maybe tag or screenshot just to have on hand to reference later on. Drive units, this is the written out version of the same thing. And so I'm putting this out to you in as many forms as I can so that you have these equations in your mind and you know what each unit means. So when you see a Newton, you know that we're talking force and you know that that is a mass times an acceleration. So it's kilograms times meters per second squared and so on and so forth. Just more on those derived units because I couldn't fit them in the same slide. So same thing. Watts, which we're going to commonly talk about in this class, is a form of power. Watts is power. Power is equivalent to joules over seconds. Same thing. Energy is joules. Joules is equivalent to newtons times meters. Work. Work is a term that is referencing force times distance. So if you're taking a force times a distance going back, work is another term for energy, right? Work and energy are the same. And then just a quick little exertion of force question here to get you thinking of changing of units, and the answer is in red. And my computer flipped the thing upwards, and I apologize that, but a man pushes a box. He's exerting a force of 150 newtons in the direction of motion. He moves 4 meters. How much work did he do? Well, Newton times meter equals joule. Same thing. What is work? It's a change in kinetic plus its potential energy. That is what work is. Or energy. It is energy. Work plus heat. Heat is abbreviated as capital Q, and you're going to see that when we do problems and equations. And when it comes time for exams too, I will give you equations to do those, but you need to know which equation to apply to any given question, because that's really the real world skill. When we're doing any of these problems on energy or power or energy being work, right? As we're working with these different forms, the skill is not in memorizing an equation, but knowing which equation is appropriate to obtain the answer necessary. And so I will always provide many, many, many equations to you in this course, but you're going to need to know which equation to use when and why. So work plus heat, heat being a way that we lose energy to frictional force, is equal to the total amount of all changes in kinetic potential, and TE is thermal energy. So this brings me into chapter 3, conservation of energy. We're going to talk about the laws of conservation of energy, and then we're going to talk about energy conserving. So we're going to talk about both of those, but I'm going to end this part of the video with derived units, and then I'm going to pick up with a part 2 in conservation of energy.